Okay, so I want to start talking about conditionals. And we're going to talk a lot about conditionals because they're really important in logic. They're also probably the trickiest one. We'll talk about biconditionals, in a bit. They're really not any trickier than conditionals. They're just, well, anyway, we'll talk about them in a bit. But conditionals are really, really important for argument. They're also really, really tricky. If students mess up anything in logic, it's conditionals. And if people, when people make really bad arguments or fall for really bad arguments in real life, it's usually because they mess up the conditional. Conditionals are tricky. I mean, you know, once you, I think, understand this, they're not tricky, but it's easy to make mistakes with them. And that's also one reason it's really important to think about them. So I'm going to spend a bit more time on the conditional than I do the or symbol, the not symbol, and the and symbol, just because they're important and people do make mistakes with them. All right, the basic idea of the conditional is it symbolizes an if-then statement. And I will say, this will become clear already. In ordinary English, a lot of times people leave out the then, right? But, ideally it's an if-then statement. And you have this little arrow that symbolizes these if-then statements. Let me give you an example of a very simple if-then statement. If it snows a foot, then TCC will cancel classes. In this region, it doesn't need to cancel, snow a foot. I think like an inch will do it. A really cold rain will sometimes do it, right? People in this region are really, really scared of snow. Either that or they just have no fear of snow and drive like 70 miles an hour. But anyway, people in this region don't handle snow well. Luckily, the college will pretty much always cancel classes whenever we have snow, because some people are terrified of it. Some people don't have the adequate amount of fear. You don't want people driving to class in Hampton Roads when it snows, right? Anyway, if it snows a foot, TCC will cancel classes. Now notice, in this statement, there are two propositions. It says two things. It snows a foot, TCC will cancel classes, or TCC cancels classes. Look, so we can symbolize this, right? This is pretty simple. It snows a foot, A, TCC will cancel classes, B, A, little arrow, B, right? Lavin uses the horseshoe, and you will see this in some logic books. I really hate it for a lot of reasons, using the horseshoe. Lavin's right, you need to know it, because it will pop up, if you take other logic classes or read stuff in logic. I really hate the horseshoe for two big reasons. One, it's just a pain in the neck to write it on an ordinary keyboard. You have to go in and find like math symbols and like pop it in there. The arrow's way easier. You just do the dash and like the little symbol, right? It's easy, easy, easy to do this with a normal keyboard. Two, as Lavin points out, the horseshoe actually means something in mathematics and set theory. The thing is, what it means is not if-then. It means something closely related, but it means something different. So you have this symbol that means two entirely different things that looks the same. It's confusing. It's stupid. I hate it. If I were logic dictator for a day, no one would ever again use the horseshoe for if-then. We won't. So know that some people do. Those people are stupid. That's just my opinion, but whatever. But they are stupid. But some people will. Those people are idiots. We will not recognize it if you see it. For our purposes, we will always use just a little arrow. Anyway, now that you've got to hear your professor rant about something, we'll move on. Here are some more if-then statements. Maybe they're true, maybe they're not, I don't know, but they're if-then, right? If you cut out all meat in your diet, you will lose weight. Might be true, might not be, but, if-then. If a baseball hits the window, it will break, right? Moxie is a dog, then she is loyal. Again, might be true, might not be. My dog is pretty loyal. I've known some dogs that aren't. But anyway, statement is saying if she's a dog, she's loyal. If you bought your car from Honest Jimmy's Car Rodeo, then you paid too much. Notice in most of these I'm leaving out the then. A lot of times people don't put it in. But it's kind of implied. You can treat it as though it's there. Look, I just made up Honest Jimmy's Car Rodeo. I don't think it exists. Maybe there is an Honest Jimmy's Car Rodeo out there. This one I'm pretty sure is true. If anytime somebody feels the need to tell you they're honest, they're probably not, right? Anyway, just to illustrate some if-then statements. You can combine the if-then with the other symbols we've seen, right? If you don't come to class, you won't do well in logic. Come to class equals C. You do well in logic equals W. Not C. If not C, then not W, right? You can build up other stuff, right? You might imagine saying to a kid, if you clean your room every week and you're nice to your brother, then you will get a train set for Christmas. I don't know. But when I was a kid, I would have loved to get a train set. I don't know if any kid still wants to get a train set. I feel like they do, right? I've been over to the Children's Museum in Portsmouth. The kids still seem delighted by the train room. So, whatever. Anyway. Right? Here we have an and, right? We're saying if you do these two things, then you get a train set, right? Clean your room every week equals C. Are nice to your brother equals B. You get a train set for Christmas equals T. Parentheses C and B, arrow T, right? If C and B, then T. If you're nice to your brother and you clean your room, then train set, right? You can do it with the others, right? If you work hard or you are naturally gifted at languages, then you will do well in French. W equals you work hard. G equals you are naturally gifted in languages. F equals you do well in French. W or G, arrow F, right? Parentheses W or G, close parentheses, arrow F, right? If you are one of these things, hardworking or naturally gifted in languages, you will do well in French. Now, hopefully this is all basic. We're just combining some stuff we've already learned. Here is something that is super important, and I want to emphasize this. With the or and symbol in logic, order does not matter. A or B means exactly the same thing as B or A. And A and B means exactly the same thing as B and A. Switch them around, doesn't matter, doesn't change when they're true or false. With the arrow symbol, with the symbol for if then, the order does matter. The order matters a lot. It's the only one of the connectives where the order matters, but with this one, the order matters a lot. A arrow B says something very different than B arrow A. Let me give you guys an example here, right? Go back to our, if it's, snows afoot, we'll cancel classes. It snows afoot equals A, TCC will cancel classes equals B. A arrow B means if it snows afoot, then TCC will cancel classes. We've already seen that, right? Well, B arrow A means if TCC cancels classes, it has snowed afoot. And think about it. A arrow B is definitely true, right? With this college, it is, very much true. If you're going to community college in Minnesota, probably wouldn't be. They laugh at a foot of snow. But in the Hampton Roads region of Virginia, it is true, right? Well, B arrow A isn't though, right? If we cancel classes, it has snowed a foot. Well, that's just not true, right? There's a lot of reasons TCC might cancel classes besides it snowing a foot. We cancel classes when we have a holiday, right? We cancel classes if there's a hurricane. And again, this is one of my more pessimistic students. You'll see by the fact his mind instantly went here. One of my students said, well, if there was a nuclear war, we'd probably cancel classes. And I'm like, yep, we would. Assuming we were still around to do that, right? My point being, B arrow A, if TCC cancels classes, it has snowed a foot, is not true because there's a lot of reasons we might cancel classes. A arrow B, if it snows a foot, we cancel classes, true. B arrow A, if we cancel classes, it has snowed a foot, or you might say it must have snowed a foot. False. Lots of reasons besides it snowing a foot, we cancel classes, right? Heck, as I said, if it snows half an inch, we probably cancel classes. So, hopefully that makes clear to you guys why the order here is important. Or, go back to our earlier one, right? Train set, nice to your brother, clean your room, then train set. Well, look, we can't reverse this and say, well, if the kid gets a train set, he must have cleaned his room and been nice to his brother. I mean, maybe he missed 1 week cleaning his room and his parents just decided to be nice, right? Maybe he was mean to his brother and didn't clean his room, and his parents are just kind of spineless and will buy him whatever he wants anyway, right? It's true that if he cleans his room and is nice to his brother, he'll get that train set, but that doesn't necessarily mean that, if he gets a train set, he must have been nice to his brother and cleaned his room, right? Maybe he was mean to his brother and didn't clean his room, but he did something really awesome that made up for it, and they decided to buy him a train set, right? I don't know. I'm trying to think of something heroic a kid could do. Maybe he saved a classmate from drowning in shallow water or something, and they're like, okay, even though your room's a mess and, you pulled your brother's hair, you're a hero, so you get a train set, right? There might be other reasons they would buy him a train set besides cleaning his room and being nice to his brother, so you can't reverse this and say, well, if he gets a train set, he must have cleaned his room and been nice to his brother. Now, I kind of emphasize this because, we'll come back to this. There's a fallacy that involves thinking that you can just reverse the order in a conditional, and it's really important. People mess it up a lot, so that's why I kind of hammer home this point. The order matters with conditionals. All right. Little bit of logic jargon we have to throw out there before we end this. The first part of the conditional, the letter before the arrow, is the antecedent. The second part, the stuff after the arrow, is the consequent. So, if A arrow B, A is the antecedent, B is the consequent. All right. And even though Lavin hasn't introduced truth tables yet, I think they're really important because, they are how we define logical terms. So A arrow B is true in every case except when A is true and B is false. Now let's think about that, right? Why do we define it in that way? Well, think about it this way. If A is true and B is true, then there's no problem with conditional, right? If it snows a foot and TCC cancels classes, then, well, it's obviously true. If it snows a foot, we will cancel classes. Well, now you look at line, you say, well, A's false and B's true, the conditional is true. Well, you might think, well, why is that, right? Well, think about it this way, right? There are lots of days where it's false that it has snowed a foot, right? If it's January and it's 60 degrees outside, it has not snowed a foot. But, we might have canceled classes for some other reason. It's Martin Luther King Day. That's the reason we don't have classes. Well, A's false, it hasn't snowed a foot. B's true, we've canceled classes. But the conditional, which just says, well, if it does snow a foot, then we cancel classes, remains true, right? That's no problem for it. Bottom line, when they're both false, it hasn't snowed, we have classes, well, the conditional is still true. If it did snow, we wouldn't have classes. This third line where A is true and B is false, that's the only time the conditional is false, right? And think of it this way, all right? If we lived in Minnesota where they don't really think much of snow, and you were going to Duluth County Community College, or I don't know what the community college in Duluth is, right? But we'll just say it's Duluth City Community College or something. If we went to Duluth Community College and we said, well, if it snows a foot, then Duluth Community College will cancel classes. You wake up one morning, it snowed a foot, and the college says, well, come on, what kind of baby are you? It's a foot, right? We need at least 4 foot here to cancel classes. You just, whatever. Make your way to class, right? If that happened, if it snowed a foot and Duluth Community College said, nope, coming to class. You guys think this is Florida? If that happened, then this conditional, whenever it snows, if it snows, the college will cancel classes, would be false, right? Because we have a case where it snows a whole bunch, and our maybe fictional, maybe real, I'll have to look this up, Duluth Community College does not cancel classes, right? So, conditional only turns out to be false if it's the case that A is true and B is false. Every other time, our conditional is true. Hopefully that makes sense to you guys both. Just you can memorize the truth table here, but also why that is.